I'm really super excited to take you all through today's session. Uh, Maybe let's get started. I'll quickly share my screen. Okay, I hope my screen is visible. I'll get into the presenter mode.
Yeah,
Yes, it is.
Okay, great. Can someone confirm me on the presentation mode?
Yeah, it is. It
Okay,
is.
thank you, thank you. Okay, so um, I'm actually like really glad to join for today's session. The reason being that uh, we have been through all these schoolings and all these phases in our life, and we learned a lot from you, professors. So I take this as an opportunity to share whatever we have seen in terms of the industrial aspects. So it will be more of a knowledge sharing session, more of knowledge transfer, because you people know much better than everyone else here. But I will try to put things in place in a nice and neat manner so that you'll be able to understand how the industry is approaching these technologies and all those stuffs. So feel free to stop me or feel free to ping anytime in the chat if you have any questions or anything you want to discuss. We are more than happy to take those points. And today we'll be focusing more on introduction to the AI agents, the term that you would have heard a lot in your social medias and your technical forums and all those places. So that is what we are going to understand how it has come up with it and what is it actually about. And followed by that, we'll be focusing on the fundamentals of AI, ML, and LLMs, not on a broader perspective, but we'll be focusing more of those topics in relevant to building an AI agent. So, AI, ML are a very large area to discuss about. It won't be enough to take in 1.5 hours. So we'll be focusing on the key terms or the terminologies that is majorly used by building an agent. So that is what we're going to focus on, the fundamental part. So to get into my introduction, already Vidya gave a fair introduction about myself, but just to add a few more things, I'm a four-time MVP for last 4 consecutive years, and I'm also certified AI professional and a certified advanced RP developer. And I also lead Chennai chapter. So people who are from Chennai, we would have connected already. But apart from that, I'm a forum moderator. If anyone is using UiPath forum, where you'll be asking your questions or getting clarified with your questions, I'm a forum moderator there, and one of the top 3 users in forum. And I'm also a top LinkedIn voice for process automation. And this is my QR code. You can scan with your mobile and you can connect me through LinkedIn. So I'll keep the screen for maybe 30 seconds. Whoever is new to me and then whoever finds me new. And if you're interested, you can scan this QR and then you can get in touch through LinkedIn. And I also would recommend all the professors here to feel free to take a screenshot of any slide that you feel like would be relevant more for you. Of course, we'll have this recorded, but anytime if you want to take a screenshot, feel free to do it. Okay, so let me move on for the next one. Great. So today's agenda will be we'll be focusing on these 3 aspects. One is on the roadmap to become an AI agent. Another one is to introduction of AI agents and the fundamentals. So for any person who wants to get into a new technology that is getting introduced in the market, it is really important to have a proper roadmap built around so that you'll be able to reach that spot and become an expert eventually. So it's really important to have a roadmap and need to know where to start and how to navigate and get to a position of being an expert. So that is what we are going to focus today, and we'll go ahead with the rest of the topics. Great. So let's start from the left side, the top leftmost. So if you are someone who is aspiring to become an AI agent or agent expert, or if you want to train your students who is more aspire to become an AI agent expert, where the future is moving towards, I would say we are already in that zone. So it's time to get into that and then equip yourself. So just recall how it was like 5 years back when RPA was booming. So in the same phase where you're now at AI agent. So it's really important to build that expertise and then be in a position that you are able to build something around that agentic technology, and you can thrive for maybe next 4 5 years and whatever the technology comes to you. So to start with that, we have to be really good at fundamentals. And I strongly believe that you people being professors will agree on that. It's really important to understand the basic concepts. And only if you have a fair idea about the basic concepts, you will know where to use that concept, in which use case, and how to use it. Unless until you don't have a clear idea about the basics, you will be like ending up in wandering different places and you may not come into a proper solution. So that's the first and foremost step, being clear at the fundamentals. And if you just look into it a little deeper, you need to understand the evolution of AI to agents, which means what is the difference between AI and agent. It is also very important because AI is there for years and agent is also there for years, but I would say it's not something new that we are looking at. It was there, but I would say it has got a little evolved from what it was like few years back. That is what agent is. It is not something very new that no one knew about it, or whatever the components involved in agent is not something new that we are going to look at. They are already there existing for years, but now they are getting combined and then they're forming a new technology altogether. So it's important to understand the difference between a traditional AI or the conventional AI and the AI agents. And followed by that, it's important to understand the architecture. Only then you will be able to understand the use case, and then you will be able to tag that components relevant to that use case, because an AI agent can have n number of components within that architecture. And if you have a fair idea about that architecture, then you will understand, okay, this component has to go for this step and go for this part of the process, something like that. And of course, neural networks, tokenizations, fundamentals like embeddings, and all those stuffs. And it's also important to understand which LLM is good for what. So, because LLM is the major and a very important component when it comes to building an AI agent. And in the market, there are hundreds of LLM models like pre-trained, and some of them are even fine-tuned by certain people, and they're posted in Hugging Face and all those places. So it's important to understand which LLM is good at what, so that for your specific use case, you can rely on those specific LLMs and then make use of it to get an optimal outcome. So to these fundamentals, it's important to understand the agent architecture. If you see them, sorry. So agent architecture will come up with types of agents and agent memory and knowledge retrieval like RAG, which is retrieval augmented generation, and context management and vector database, and all those concepts needs to be get went through once. And after that, it's important to understand the prompt engineering. You might be wondering, prompt is just a text like a natural language input. Like, why we really need to focus on learning on a prompt engineering? It is really, really important because when it comes to real world in an enterprise or in an organization, any LLM model that you're going to use, it could be just a Gen AI solution or it could be an agentic solution. When you're using LLM with any of this, LLM will look for a natural language. And it is really important to have that primed and tuned in such a way that the LLM model make use of that natural language input in the best way. So for that, you really need to define those prompts in a proper manner. Only then the expected outcome will be received. Else, it will be like it may not give that level of accuracy that you're expecting. So
Lenny? Hello? Hi. Uh, 1 second, guys. I think there were some network issues. We'll get Palani back in the session. Guys, I think we are working on getting the speaker back. Thank you for your patience.
Yeah. Palni's had some network issues. He's
Yeah.
going to join back in a minute. Yeah.
Yeah, he's back.
Palni's back.
One,
Unmute. Yeah.
1 second. No. Palani, you can unmute yourself.
All right, I'm so sorry. There was a power cut, so just join back. Let me share my screen, and then we'll continue. Okay. Hope my screen is visible on presentation.
Yes, yes.
All right, great. Thanks for being patient. So let's continue from where I left. Um, so I was telling about the agent architecture, like what and all we need to be aware of. And then followed by that, I was also mentioning the importance of knowing about the prompt engineering because prompt is very important in terms of expecting an LLM model to process our input in the best way so that you get the optimal outcome. And followed by prompt engineering, we have to now we have understood all the basic concepts like what are the fundamentals, agent architecture, and prompts. And after knowing all this, it's now let's step into the advanced concepts where you will be getting to know about multi-agent framework and AI agent and agentic workflow. So what is the difference between AI agent and what is it about agentic workflow? And we'll also look at multi-model and multimodal agents. So multi-model is more like you can use n number of LLM models, while multimodal is like you can use any format of data to process. It could be a text or an image or an audio, it could be anything. So an agent can be built on both of these, like multi-model and multimodal. And today, especially, we'll be focusing on the fundamentals of AI ML and a quick introduction about AI agents. And that is what we are going to focus for today. And this is a very famous diagram that everyone would have seen in Google or wherever in books, like for any reference in terms of artificial intelligence and their branches. This is quite famous across the globe. So we're not, these many concepts are there within AI/ML, and it doesn't confine even all the concepts. It's very like high level, it is being captured here. But among these, we are going to focus on few of the concepts, which is like intelligent robotics, and we'll be focusing on Gen AI, and then LLM models and agents. And these are the concepts that we are going to focus for today. And the reason being that these are the core concepts that we'll be using the most when building an AI agent. An agent can be built in a more sophisticated or very complex level, but to start with building an agent, these four concepts are really important in terms of building an agent. So we'll be focusing on these concepts today. Okay. Let's try to understand first the difference between Gen AI and agentic AI. Okay. So Gen AI is something that everyone is aware of. Everyone would have used ChatGPT. Everyone would have used even other LLM models, which are open source like Grok, DeepSeek, or Claude, Anthropic. It could be anything. So, so Gen AI is something like you use an AI system to generate anything. It could be a text or an audio or even a video or being any content. So an AI that is able to generate text by understanding an input text or understanding a document or understanding another set of input is so called as Gen AI, right? And so that's why it's so called as creative. Let's look at the right side because that is something everyone knew about it, right? So if you see, Gen AI is more of creative in nature, and then it's more like output oriented. So whatever you type in, based on it, it'll create an output. That's it. Like that's what Gen AI does. And again, content based. So it is able to generate contents. It could be of any format. And you don't necessarily need to use any external tools like APIs or anything like if you choose one LLM model, let's say ChatGPT or OpenAI LLM models, you use only that tool and you don't use any external tools like Salesforce or ServiceNow or do anything with that. So you directly use an LLM model, give an input and get an output. That's it. And it doesn't get adapted from real time because there is something called a context window or even like those are like more of pre-trained models because they are trained on large corpus of data and they don't get adapted on the real time and then they don't get updated with data. And if you have to do that, you have to really make a fine tuning there. And for making a fine tuning, you have to involve external tools. But Gen AI doesn't happen with that, right? And of course, with content generation, as I said, it will be able to create contents and then make decision based on the input patterns. So it can make a decision, but not to an extent like an agent or a human does. So it makes a decision based on what an input is given to it. So that's what the limit is for Gen AI. And if we just completely shift from right side to left side, it's completely the contrast one when it comes to agentic AI. So in agentic AI, it is more of autonomous. So so this is a keyword what defines an agent or what defines or what it makes a big difference out of all the other AI systems. So any artificial intelligence system, if it is able to make a decision, out of that decision, it can build a text or it can do some action, it can even trigger an API, it could do anything. But if that decision making is done by AI system itself, based on certain patterns or based on certain rules, based on certain informations and datas, if it is able to make that decision by itself without relying on any human, then it is called as an agentic AI system. That is what this agent is about. So many people are thinking about if an agent is able to do an action by itself, then it is an agent. If an AI is able to give a chatbot or a text out of a chatbot, then it is also called as an agent. But that is very generic term. But the actual term or the definition that holds agentic AI different from other AI system is if an AI system is able to make a decision by itself autonomously, then it is so called as an agentic AI system. Okay. And after that, after taking a decision, it has to drive towards a goal, right? Because a decision has to be taken only on top of a goal. So it's more of a goal oriented, right? And if it is able to adapt on real time, and then you can bring n number of tools and platforms within that, and it will be able to adapt to those environments, whatever changes it came up with. Okay. And it also uses external tools and APIs. When I say tools, it can be a database, or it can be an ERP system or a CRM system, or it could be a web application or a desktop application, and it can even use API calls. And again, continuous adaptation is back to the real-time environment. And again, autonomous system and independent decision making. So if we compare Gen AI and agentic AI, one point that makes it of a huge difference is that Gen AI is used for generating content. Okay, that's it. But when it comes to agentic AI, you can generate content, you can do anything, you can make a text or action, but that's not just an AI agent is about. An AI, if it is able to make decision autonomously by itself, then it is called as an agent. And that can lead to an outcome of a text or an action or just an API call, could be anything. But before triggering an action or before triggering an API, or before creating a text or before creating any content, before to all these steps, if there is any one decision making step which is done by AI itself without any human intervention, then it is called agents. As simple as that. Clear? Let's go for the next one. So let's get into the components of AI agents. Okay. And I would like to start with LLM models. So LLM is large language models. So large language model is one of the branches within Gen AI. And everyone got to know more about this LLM once ChatGPT came up with their model called OpenAI LLM models. And followed by that, many vendors came in, like Grok came in. And then Grok is from Tesla, I mean, Elon Musk, and DeepSeek from China, and Anthropic Claude, and Perplexity from India, from an Indian like Srinivasan. Everyone knows about him. So there are many LLM models which came up in the market, and then everyone is more accessible to it. So if anyone is using those models in your mobile as an app, you basically give a text as an input, and that LLM model will try to understand the text, interpret that, and then tokenize, and then based on that text, it will try to rely on its pre-trained model and data. And out of that, it will try to generate text one after the another. And it will try to build an output and give it to you as an output text. That is what typically an LLM takes in as a text and gives out as a text, right? But along with this LLM model, if I'm trying to add a few more components so that LLM models enables to make a decision and not just give a text. So if that is possible, then it is called an agent. Let's see how it looks like. So I'm giving a text to an LLM model. And usually LLM model is more of a Gen AI component, right? So what Gen AI does, it will receive the input, process it, and give some sort of an output based on our need. But I don't want to just give that because I don't see any decision making happening here. And I don't see any valuable outcome coming out of it. Like it is just like text in, text out. That's it, right? But if I add a set of knowledge base to it, it could be documents, videos, and images. That is so-called knowledge base. And along with the knowledge base, if I'm adding a memory to it, so that even if the context window is out, it will be able to still rely on this memory and retrieve the data. And it will be able to think like a human who have all those data in here, I mean like his or her memory, and then try to do things, right? So if I'm adding a memory layer there, and along with that, if I'm adding a reasoning layer there, this is very, very important. When I say reasoning, it doesn't mean that we are adding a separate component to do that reasoning. It's not like that. So we are making use of the LLM model itself to do that reasoning. How? when you're trying to give an text to LLM model, it gives an output. And if you try to make use of that output and give it back to the same LLM or maybe a different LLM and ask that to look at it and give me the best output, which means it goes like a cycle, like an iteration. And if you do that iteration for n number of times, and after reaching an optimal number, once you receive a very perfect output. It could be a text or a code or even an HTML or a CSS, or it could be a video, anything. But after all these iteration, if you're receiving the most prominent, the most refined output, then it has gone through certain reasoning through an iteration. And that is what I mean as reasoning here. So you enable that reasoning with the help of iterating through an LLM model for n number of times. And followed by that, if you are using an external tools or an APIs, like like you have added a knowledge base from left side. If you see, you have added a knowledge base, you've added a memory, you've added a reasoning layer. But after adding all these, you have to do some sort of thing, right? It could be generating a text, or it could be doing an action, or it could be a trigger to another application. So for that, you need an external tool or a connectors or an API calls to do that. And I can also enable that and add that as a component to this, all these layers. And now it does, so goes in a like iteration. And after all this, it performs an action and not just text. And if an LLM model gets accompanied with all these components, which are the core components of an agentic architecture, then you will get an agentic AI solution. So now you can understand how it differs from using a simple chat GPT or an LLM model with an agentic AI solution. So when you adding an additional component or a set of components to an LLM model, enabling that LLM model to be the key reason to have the autonomous decision making happening, then it is called as an agentic AI solution. Clear? So now I hope that what is agentic AI is very clear about to everyone, but it doesn't end there. So don't look at the bottom two branches, just close your eyes. So let's recall what is agentic AI is about. So agentic AI is something that is able to make decision autonomously by itself, correct? But agentic AI is a broader concept, and it consists of both AI agents and agentic workflow. Clear? Because when you come into organization or when you are trying to solve, you don't need to get into an organization, leave that. Even if you're trying to solve a use case with an agent, you need to understand whether you're going to use an AI agent or you're going to solve that use case with an agentic workflow. These two terms are very different from each other, and these two terms fall under the branch of common concept that is called so-called as an agentic AI system. Under agentic AI system, the first branch on the left side is so-called AI agents. So let's take, I'm trying to, I'm a daily user of Salesforce, and there is another person who is a daily user of ServiceNow. And we use Salesforce on a very high level or even on a deeper level on a day-to-day basis in our daily work. And the same person use ServiceNow on a day-to-day work. And I feel like most of my work needs my input and needs my decision there to do some task around it. And if my decision is not there, if it is a rule-based, I can easily solve that with an automation solution, right? But if my input is needed, maybe 30 to 40% or maybe 70 or 60% can be solved by an automation with an AI powered to it. And I can still involve whenever there is a need from my side. But if I'm completely looking autonomously for my system, that is Salesforce, then I need to bring in AI agent. So which means an AI agent are designed to perform specific tasks or achieve specific goals in a process, right? Which means an AI agent can be built for a specific platform or a component or a system where it has got a specific set of tasks. So you basically use a term called AI agents to solve a specific set of tasks which are used within one specific platform or one specific tool. But let's say I'm building an AI agent for my Salesforce system, and my friend who is using ServiceNow is also building an AI agent for his system. So when I say AI agent, people here who have joined would have used UiPath AI Assistant, right? That is also called as an AI agent because you are using assistant for that specific within that specific ecosystem of UiPath, and then you are trying to do something around it. And it is used to solve specific set of tasks, right? And that is what is called as an AI agent, simply like assistants, or maybe Siri, or maybe Alexa, or called AI agents. Now I have built an AI agent for me, and my friend who is using ServiceNow also has built an AI agent for him, for his purpose. And now, when it comes to a business process, it doesn't end up with just using Salesforce, or it doesn't end up with just using ServiceNow. A business process might go through Salesforce and also with ServiceNow and also with Oracle and also with SAP. It can use multiple number of platforms, right? So which means specialized AI agents built for those tools will be there with each of those platforms. And along with those platforms, there will be some external steps involved. And when I combine all these steps along with these platforms, it becomes more like a business end-to-end process, right? And that sort of agents being involved and that solution is so called as agentic workflow because it doesn't end up with just my platform. I'm trying to use with another agent and another agent, and all these agents are being used along with another set of tasks which are getting handled in different spots and places. So it is trying to solve an end-to-end business process flow, right? Like a workflow. And when you build an agent to solve a business use case end to end, then it is so called agentic workflow. So these two terms are really, really very important. That's why, like, only then you will be understand, okay, I'm going to build an AI agent and I'm going to build an agentic workflow. So you'll have a clear mind about how you're going to solve that use case. So AI agent is to solve specific set of tasks, like 1, 2, 3, 4 tasks, which is performed within a platform. And if I try to combine with multiple agents, or maybe with just one event, one agent is fine. Maybe the process uses only agent from Salesforce, but it also has other steps like inbound and outbound, so that it solves an end-to-end business process. Then it is called agentic workflow. Okay. So let's have a quick example. We saw an analogy, right? Like we saw these number of components involved together and then solving a use case. That is actually a very good example of an AI agent, like customer support AI assistant, virtual personal assistants like Siri, Alexa, even Autopilot from UiPath and Copilot from Microsoft. These are all AI agent, right? And within these assistants, you can build agents, and then you can build agents on a specialized nodes. Let's say Copilot agent can be built for a specialized purpose, and Autopilot can be used for a specialized purpose. So, and you can build those specialized AI agents and then give it to those users whoever wants it. So this is a good example of AI agent. But let's see how agentic workflow will differ from this. Now you can understand, I believe. So there is a couple of steps inbound and outbound before the agent getting involved, where the bot is trying to extract data from machine backend system. And then it goes through an agent where monitor machine performance done, and followed by that another agent where the maintenance needs are predicted and the production schedules are adjusted automatically. And after that, it goes to another step to the bot where it updates the backend system with the appropriate changes, whatever has happened within the schedule. So you can see some workflow going on here, and it's just trying to solve an end-to-end process or a workflow like a smart manufacturing system. And this is what called as agentic workflow because you're solving a workflow by involving agents into it. And that's why it is called as an agentic workflow. I hope it's clear now. What is what is agentic AI? which is a broader concept. Under agentic AI, you get AI agents and then agentic workflow. Clear? All right. Now you might be having a fair idea about what is an AI agent and what is an agentic workflow, right? But we people have gone through a lot of automation use cases. And it is really, really important to understand the difference between automation, agentic workflow, and AI agent. I don't want to get into this deeper, but I want to take the example or maybe the core function starting here. So when it comes to automation, it's purely rule-based, Boolean logics. And when it comes to agentic workflow, it still uses Boolean logics and fuzzy logics. And when it comes to AI agent within a system or an assistant, like kind of an assistant, it is purely autonomy and fuzzy logic. So let's get into the example here so that you get some idea. And when it starts with automation, you will be like, send a Slack notification every time a new lead signs up on a website. Pretty simple, like a webhook trigger kind of thing. So whenever a person logs in, it triggers a notification in a Slack. Let's get into the agentic workflow. Analyze, score, and route every website inbound lead using ChatGPT. So, so maybe, okay, let's park it here. Let's look at the AI agent and then we'll come back to agent workflow. You'll get an idea. So perform a full internet search on every inbound lead and update infos. So it is trying to, so when it comes to AI agent, it's more deterministic, like you know what needs to be done. And then you try to solve a specific set of tasks that is defined. But when it comes to a larger scope as a process, just shift from right to left. Now, if you see the agentic workflow, it doesn't end up with just searching through internet. You analyze it, you give some score, and you route it also for every inbound lead. So, so the workflow and agent are are lying with the difference of having a thin line between them. So an agent is more of a very defined scope, a limited set of steps. But agentic workflow is of a larger step. Just keep it simple as that, okay? And this is a journey of UI path to agentic automation. You can see here where it started with 2018 of UI-based automation, and then API, and then structured data, and then unstructured with IDP, like document processing. And they came up with Gen AI activities, and now we are in agentic processes. And by April 30th, last month 30th, agentic platforms were launched, and you can expect them soon in public preview. All right, so till this, you got a fire idea about what is an agentic AI and what are the branches, and what is AI agents and what is agentic workflow. So that gives an idea about, or gives a good note of introduction about AI agents, right? Let's get into the fundamentals now. And we are going to focus on these fundamentals in terms of building an AI agent. Okay. So let's start with again LLM models because is there any queries? Yeah. Okay, maybe before I get into this, let me try to answer a few of the questions here. Can we say Copilot as an LLM? Copilot is more of an assistant, sir. It can be like an AI agent. It incorporates or it has some LLM model within that, but it is not just an LLM model, right? Okay. It is still an AI agent kind of thing because Copilot is more of an assistant, and an assistant is so called as an AI agent. Is driverless car an AI agent? Of course, you're right. Driverless car is an AI agent. That's right. RPA is then a rule-based, right? Exactly. It's a rule-based one because robotic process automation runs on a process which can have hundreds of steps or even thousands of steps. That is fine. But those steps are well-defined and standardized steps. So you know what needs to be done on a particular step if there are many decision makings are happening. So you have an if condition, you know, then and else what needs to be done. So it's purely rule-based. But agents is not rule-based or it is not bound to handle only rule-based. It can handle any use case. Let's take a example of use case example one, where it is purely rule based, and we earlier used RPA to solve it. And when it comes to use case two, which involves some sort of a human intervention, and then where we used Action Center and some sort of a place where human input can be given. And that's the second stage. And now we are in the third stage where um, human intervention is needed, a human decision making is needed, human input is needed, but we are not relying on them like how we were relying previously. Maybe previously you would have relied 60 to 70%. Now we can rely only for 5 to 10%. You don't need to even wait for their inputs. You can use these LLM components and build like a human brain kind of thing and then solve things. That is what agent is doing. And someone has lost audio. I hope I'm audible. Can someone confirm, please?
Audio is good,
Okay.
Palani. Yeah.
Okay. I think Sweet Masai, I think try to rejoin so that you'll get to see it. Yeah. Perfect. So let's continue with the next set of concepts. Feel free to type in your questions in the chat so that I'll try to pause and then look at it and then I can try to clarify them. Okay. Great. So let's get into the LLM. And you can see in the red fonts that LLM is the brain for an agent that handles reasoning and decision making. So you would have seen a lot of concepts so far in this session, like with whatever we discussed so far. Now with this statement, you will be able to, not just with this statement, whatever slides that we are going to look forward, based on that, you will be able to connect the dots, how it is connecting with each other, I mean, each of those components, and how it is contributing an agent to perform like a human. So I would really emphasize to look at or stay focused on the upcoming slides more so that you will be able to understand and connect the dots that we discussed previously. Okay. So let's divide LLM in 3 different stages. Start from left side. You give a prompt to LLM and you get an answer as an output. That's the first stage. Very simplified use of LLM models. And let's say I'm asking an LLM model that can you book a meeting with UiPath community tomorrow? I'm asking. Maybe I'm putting like this. What is UiPath community? Like a very simple statement like what is UiPath community? And it will be able to understand based on the pre-trained data and it will be able to give me an output, correct? But as a next step, I'm asking the same LLM model saying that, can you schedule a call with the UiPath community team tomorrow based on my calendar? And if I'm asking an LLM model, you can even try in your ChatGPT. When I'm saying this, you can try in your ChatGPT. It will be saying something like, I don't have access to your calendar. I will not be able to do it. Or I don't have any data related to UiPath community. I have only data to this level or to this year, right? Because if you see ChatGPT and any other outsource, I mean, open source LLM models, they will be trained only till certain period of time, like 2024, 2025 year or December, like November of last year, something like that. So if you ask anything after that time period, it will not be able to answer, right? So on that note, you need to enable that LLM model with some additional knowledge base or a data source. And if you add the data source along with that pre-trained data within that LLM model, the LLM model will be able to first able to check within the pre-trained data. And if it is not able to find an answer to a question, and it will rely on those data source. And then from there, it will try to get the best data and give it to you. And you can see some sort of a data getting retrieved from those knowledge base. And based on this data retrieved, it is able to generate an output text for you, right? Now you need to catch the 2 terms that I used in this sentence. Retrieving data from a knowledge source based on which it is able to generate a text. So the 2 key words is retrieve and generate. And if you combine them with the acronym like retrieval augmented generation, that is what is called as RAG. So you are augmenting or you're enabling a generation based on the retrieval. So that is what retrieval augmented generation. So this will happen when you add a data source or a knowledge source to an LLM model. And based on that, if an LLM model is able to generate an answer, then it is called as RAG. And that is what is there in the middle picture. And along with this RAG, if I'm adding additional set of components like reasoning, like tools and memory layers, then it becomes an agent. Now you're able to understand, right? So this is the importance of LLM model in building an agent. So let's look at, okay, you might be wondering, you're right, okay, LLM model is important, I understand, but how will I know which LLM model is good for what? And this slide will answer that question for you. So you can look at the left side with the features and the matrix on the right side with n number of model names captured. So it's like GPT-4, GPT 4.5, O1, O3 Mini, Gemini 2.0, and Claude 3.7. These are the most commonly used LLM models in every enterprise or solving an enterprise level use case. So this might be a little overwhelming. You might be, you may not be able to understand. Sir, there are too many things to compare here. How will I understand? Let's get it simplified. And let's say if you're relying on an LLM model to generate a code, then it is better to use an O3 mini. And in a given O4 is good. Like you can still O3 mini. It's just a little later or a previous level data. But mini ML models from OpenAI is really good. And if you're expecting for a content text generation, you can rely on 4.5 Claude 3.7. And if you are trying to make use an AI for a generic AI use, then go for GPT-4o. And if you are trying to pass different types of inputs like a video, text, or an image or a document, anything, then it is better to use Gemini 2.0 Flash. And if you are using for a deep logic and a problem solving, then go for Anthropic Claude 3.7 or OpenAI O1. Okay, O1 is an open research kind of thing. So these are the common LLM models which are really good at these aspects, right? So this is again the LLM architecture. Now you understood what is the importance of LLM model, how an LLM model basically works. But it is important to understand the architecture of LLM model. And this is an architecture diagram provided by OpenAI when they launched their LLM models. These terms might be like a jargon kind of thing, like maybe too much of things. Let's try to simplify this. A simple example of LLM, okay? When you're referring to this image, start from the bottom of the image, right? And you can use your ChatGPT in the meantime, like how it is going to work. You can see that. And start typing as London is the capital of. Stop it. And once you type in the London is the capital of, it will try to take that as an input text. And once the input text is given to it, it will try to split those text into tokens. So we as a humans, the least possible split of a sentence is characters, right? If I'm reading this London as a capital of as a human, to the least I can split these into characters as L, O, N, D, like that, right? As a human, we split them as characters. As an LLM model or as an AI system, at least it will be able to split as tokens. And in generic, one token can be a maximum of 1.5 characters or words, right? So once you give a sentence to it, it will try to split them into tokens. A token can be a word, a token can be a character, or a token can be a punctuation or a mark, anything. So a maximum, it's like 1.5 characters, if I could recall correctly. One token is like 1.5 characters, I guess, or maybe 1.5 words, I guess. So once they get tokenized, right, then they get passed to an embedding layers. So what embedding layer does is, convert these tokens which are associated with token IDs and then put them in a vector DBs. Vector DB is a open 5-dimensional or multi-dimensional space where it will try to place those words or characters which are identified, which are tokenized based on the proximity. So this LLM models will already have some data within it, right? And whatever data you are giving to it, that input will be split and then placed with those existing pre-trained data based on the proximity. When I say proximity, the level of closeness that they are coming up with. And that kind of embedding goes through different kind of iterations, like million times of iterations, and then tries to position them within the vector DBs, right? And then this is between just the embedding layers, and that is what you would have heard as attention layers. You would have certainly seen how basically a transformer model will work. And that is where we are getting to the next phase, that is transformer blocks. So after embedding with number of tokenized IDs, it will try to go through a mechanism called attention, where one vector will get compared to another vector parallelly, right? And if you see all the recent LLM models, they are all built with this transformers. And that is why those LLM models are called as GPT models, that is generative pre-trained transformers. So generative pre-trained transformers. So it will be able to generate text based on the pre-trained data with the transformer mechanism. That is what is GPT is. So under this GPT, there are multiple layers, like first layer is attention layer, and then multi-perception layer, again attention layer, multi-perception, attention. So it goes like iteration, like n number of times. And during this n number of iteration only, it generates a lot of heat. And for that reduction of heat only, we are using GPUs. And GPUs, in order to even contain the heat, we are trying to soak them within water and then all those things. It's a big concept. So now once you give the text or a statement, it gets split into tokens. That is so called as tokenizations. And after tokenization, it gets embedded where a token ID is tagged or placed in the vector systems. And both of this tokenized and tokenization embedding together is called as vectorization. So that is also important to understand. And after vectorization, it goes through the attention layer where one set of word is compared to another word, or it's pre-trained set of words, and whichever gets closer to it, it becomes as a next set of word. So when I say London is the capital of, the next set of word could be India, it could be Paris, it could be Europe, or it could be anything. So it will try to bring those words one after the another, and once after reaching the best one which has got the maximum score or the maximum proximity, then that will be taken as an output and given to you in your interface. So after going through, that is what will happen within the transformer blocks. And after going through these many iterations and forming the complete sentence, it again detokenize and then generates a text and then give it as a readable text. And that is what you receive as an output. And if you see at top, after output layer, it again comes as a tokenized layer only. And that tokenized layer get detokenized and then it gives you an output as is the capital of England. So this is how the LLM model basically works. So starts with an embedding, starts with tokenization, embedding, these together so-called as vectorization. And after that, it gets into a transformer block where it reaches the attention layer, where it tries to compare with the other set of characters or the words within this pre-trained data. And then it goes to multi-perception layer where it tries to connect with the next set of words and goes through an iteration. And after going through this, it comes again as a tokenized output, and that tokenized output get detokenized, and then it comes as an output text. This is how the layers get broken down, and you get the output in LLM models. Okay. So if you see within this LLM model, and now I hope you understand the importance of LLM model, how an LLM model can be used in an agent, and how basically an LLM model will work. And out of all these, the first and foremost input for an LLM model is prompt, right? So prompts are very important, and those prompts are tokenized in forms of tokens. which means the tokens are individual units of prompt text that LLM model processes. It can be a word or parts of words or even a punctuation mark, right? So now you understood about the tokens. Input part is clear. And after given the input part, what happens within the LLM model is clear. And then there's one thing that we left that is considered while or even before processing that input within an LLM model. That is so-called as temperature. So if you see in any LLM model, you can define this temperature, which will help and define that LLM model in such a way that LLM model, you have to create only creative contents, or you have to create only clear, precise content. So that level of definition is possible by bringing this temperature value. And if the temperature is set less than 1, like 0 to 1 between any value, then you get the most precise output. But if it's defined more than 1 or 1 to 2, like maximum is 2. So if you're trying to provide more than 2, then it provides a creative or a random content. It may not be precise. So based on your need, you can set this temperature, and you can get the expected outcome based on the number that you are setting, right? That is what a temperature is. So it could be a precise value or a precise text or a precise document or a precise video or an image, or it could be a creative image, creative content, could be anything. And it is possible based on the number that you are defining. And that is so-called as temperature. Right. So RAG is something that we saw when we discussed about LLM being used in 3 different stages, right? So again, this is the RAG architecture, like on a more detailed note. Let's say I'm giving an LLM model a text or a user query, and then if it is within that pre-trained data, it will be able to generate. And if it's something out of the pre-trained data, it has to rely on some knowledge source. And I would have given, or I would have prepared a knowledge source with some PDF text or anything. And then I try to embed them, and then embed in the sense like I'll try to tokenize them, or even tokenize before tokenization, I'll try to chunk them. Like a document of 100 characters can be chunked into 10 characters, 10 characters, 10 characters, like that. And all these chunks will be placed in vectors through this vectorization process. Now, I hope you'll be able to understand what we went through in the previous slide. So you receive an input, tokenize it, that is chunk it, and after chunking it, do an embedding, and after embedding, you do a vectorization. So that once you call an LLM model with this vector DB in place, so your text input will go to that vector DB, and then your input is what is in blue color, and it will be the vector DB will be having some chunks. Whichever is lying to the closer proximity, it will be picked, and out of those picked items, it will try to refine and then give you an outcome. Right? This is what is context grounding. And RAG is equal to context grounding. If you see in UiPath, we use a term called context grounding, which is actually so called as RAG. Clear? So some of the major or fundamental concepts of LLM is what we have seen so far. What is LLM? How can LLM be used? What is the architecture? How it basically works? What is RAG, and what is tokens, and what is temperature? And I also want to emphasize this cool slide, which I really liked from UiPath 1, which was shown during our forward event the last year. And when it comes to agentic automation, our left brain will be more of a structured rule-based, while the right brain will be more of an agentic solution. So it goes hand in hand and creates an agentic solution. And that's what future is moving towards. And to get into this place or spot, you really need to understand the basic concepts that we have seen so far. So this is a timeline, and we have already crossed this April 30th, and some of them would have already got the access. Or if not, you can be in the wait list, and then you can get to see the access anytime. And with that note, I would like to thank everyone for your time. And now let's get into the Q&A part. Let's get into the chat and see if there is any questions.
I'll stop the recording now.
Yes. I think I already mentioned this, Srikumar sir. Like one token can be, a thumb rule is one token could be a maximum of 1.5 words. That is 1.5 set of characters. And if you want to know in precise about I can help you with that. I'll do one thing. Hugging face. Token. I'll get to that, right? No, I need that. All right. So this is for llama. So, but there is another model. If you can search on a similar line, I'll stop sharing the screen for a second. I'll give you that. Just a second. Yeah. Okay, so I'll share my screen. Hope you can see my screen. So this is a tokenizer playground. I will just give you this URL. This is open source. This is the URL. I'll put it in the chat. Anyone wants to know about how a tokenization is calculated, you can just use this. And let's say, hi there, I'm Parni. Okay, so I can see 5 tokens of 18 characters. And this is for GPT-4o model. I can choose any model I need. I can choose Claude or Group 1. And if I'm trying to do it, then it becomes 6 tokens. And you can see the difference in tokenization, right? Or if I'm using LLama, again 6 tokens. Or Mistral, and again uses 6 tokens. So you can use this URL to understand the tokenization, sir. It'll be useful for you, I guess. Hope that answers your question, sir. Sri Kumar. Right. The URL is in the chat. You can refer to it. I see another question. Let's just in agentic AI, tools are important component. That's right. How other UiPath libraries or code could be used as tools? Are there any other external tools from other vendors in same external marketplace? That's a fantastic question. So when I say tools, it could be a memory layer, it could be an API tool or a connector, it could be an LLM model, it could be anything. And when it comes along with UiPath, you can enable these memories, or you can even enable these tools and components within Agent Builder. And I hope you would have seen about Agent Builder. If you have not, it's already available in UiPath Academy to just go through, or you can refer in YouTube how Agent Builder is working. And within Agent Builder, you have an option to create a memory layer, and you also have an option to choose your tools. And when I say tools, you can make a connector or establish an API call, or you can even call an RPA bot. Or out of all these, once you have built an agent, you can even call this agent in another agent as a tool. So there are so many other options available. So it's already available in UiPath, like an inbuilt feature. I hope that answers your question, sir. May good. Okay, so very interesting questions. Like if you are still looking for a clarification, I'll give my LinkedIn profile. You can reach me out, and this is my LinkedIn URL. I'm just putting it in chat, and you can call me anytime you want. Yeah, clear. Great. I'll stop sharing my screen and hand it over to Anju and Vidya. Thank you.
Thank you, Parni. Vidya, you want to bring up the slide?
Yes, I did.
Yeah, thank you everyone for being part of this session. Before we wrap up, just a quick reiteration. I'm sure most of you have already received a couple of communication from our end on UiPath Agent Hack. Just reiterating the program. This is specifically designed for students in India. And, the entire program is kind of split into 4 parts. Phase 1 is really the upskilling sessions. Phase 2 is where the idea submission happens. Phase 3 is regional finals, and phase 4 is the finale. So we are right now in phase 1. From April, we've started upskilling sessions, and we plan to continue doing this until mid of June. This is where, we need your help to ensure students from your institutes make use of these upskilling sessions, which is led by our experts. We already have around 10,000 students who've attended these sessions and upskilled themselves, and they're quite prepared to participate in hackathon. Actively, we've started receiving the ideas as well. So if there are any students from your institutes who've not made use of these upskilling sessions, we would urge you to encourage them to register for the upskilling sessions that's coming up, and be ready to participate in hackathon. Hackathon is something, idea submissions have started, and hackathon has a lot of benefits in terms of, global recognition, prize monies and stuff. So just, make use of that, and please do, help us spread word amongst students to take up this opportunity. Screen has the links where students can participate in hackathon. This link will lead them to both submit ideas and also, take up upskilling sessions. So I'll leave this screen on for a minute for you guys to either take note of it or click a picture. We'll also, send out one communication email post this session, which will cover these links. And this is another one. We run something called UiPath Student Developer Champion Program through the year. This is something that is happening from past, 5 years, 4 to 5 years, wherein students from across the globe, participate. And we pick one, student developer champion from each of the institutes, and we work with that particular champion through the year to ensure that that particular champion drives enablement and excitement in the school for students to learn more about automation. So this program has been very active and very successful, amongst the student community. Some of your institutes, we already have representation. We have student champions who are doing a great job of, spreading awareness about automation, having students learn more and more, make use of the resources that UiPath specifically has for students, both in terms of MVP availabilities, resources, and all of that. So, but for the institutes where we do not have representation or where we don't have champions assigned so far, for those faculty members, for those institutes, please be aware that the applications are open all through the year. Students who are interested can go ahead and apply to become a developer champion, or faculties also can feel free to click on this link and nominate students. We run this application evaluation and selection process every 4 months. So 4 months back, we did have onboarded a lot of students. We will have in June, we'll have another round of onboarding that will happen. So if there are any students who are interested to apply for this particular role, please go ahead and make use of this program. Here's the link for one to apply for the program. Yeah, so with these things, I think we're done for today's session. We'll also see if we can, if there is any other topics that you'd like us to cover, if there is any deep dive sessions that you want us to, continue as a next session, please feel free to write to us. I think our email ID, most of you have our email IDs. So if required, we will have a follow-up sessions. But otherwise, I think we had a great session today. Thank you, Parni, and thank you everyone for joining us for the session. If there is any questions, we'll be happy to take that. Are there any finishing school training programs available for students in 3rd and final year of engineering? Yeah, so the Student Developer Champion program that is available is specifically for second and third year students. Usually we don't onboard champions from final year because they're busy with the internships and other things. But second and third year students can feel free to apply for that particular program if that is something that you're asking, Shrikum. Thank you. Cool. I think this is good. Thank you all. And yeah, looking forward to having a lot of students from each of your institutes participate in the hackathon program and also be part of the Student Developer Champion champion program that runs through the year. Thank you. Yes, absolutely. We will, you're all part of our communication.